Toxicity is the capacity of the chemicals to cause injury or death. It could be harmful to the tissues, more seriously to organs, and most serious is the disruption of the biological functions of the whole body. And the effects of the toxins can be additive, which means the impact is the sum of the effects of the individual compounds. Or synergistic. This is really dangerous. The synergistic means the toxic impact is much greater than the sum of the effects due to the interactions of the individual chemicals to each other. For example, for a mine worker, if you smoke, you are more damaged by the radioactive exposure. If you work in the uranium mine and you also smoke, and the radioactive damage could be much more than you just exposed to the radioactive material in the mine and to the smoking. Okay. So the risk factors, every individual responds to those toxins very differently. So the toxicologists use LD50 to measure the toxicity of a compound or chemical or substance. LD50 means the dose required to kill half of the individuals in the test. We do not use humans, okay, except the World War II and Hitler used humans as human objects, or Japanese use the Chinese people as so those extreme cases, we do not use people as experimental objects. We use plants, we use animals like rats to study the toxicity of those toxins. It is very interesting. For some of the toxins, very toxic, if you decrease the concentration a lot, and you can use it for very beneficial procedures to treat muscle spasm or cosmetic procedures, just using the botulinum toxins, which is demonstrated here. So toxins do not have to be toxins depending on the concentration sometimes. So how are we exposed to the toxins? One is breathing, okay? Vitality means how fast a substance could be absorbed by the body through inhaling. And the examples will be the volatile organic compounds, such as paints, nail polish, and pesticides. I have an Annenberg assignment for you to do, so you can see how scientists carry out environmental health experiments to study the compounds, how harmful they are to the humans. The second way is through water. So some of the toxins are water soluble, and some of them can be accumulated by the fat tissues, such as DDT. They are more soluble in the fat than in the water, and they will be accumulated in the fat tissues of the animals and human. And it's called bioaccumulation, right? So when the trophic level increases, the concentration will be magnified much higher. Persistence of a toxin, that means it resists being broken down. DDT is one of them. And many herbicides, insecticides, and pesticides belong to this category. Persistent organic pollutants like DDT resist the breakdown. It's very persistent in the environment. The half-life is 1 to 20 years. So it takes a long time for them to be completely gone from the planet. So we're better not to use those chemicals a lot. So our textbook gave us this table, the nasty compounds, okay? Most of them are pesticides. The PCBs is industrial widely applied chemicals. It's used for variety of the processes and purposes, including electrical transformers, capacitors, as heat exchanging fluids, as paint additives, and there's a river in the United States. The sediments were so contaminated by the PCB, and people had to dig out the sediments and burn them off and put them back in the river. That is very, very expensive. But unfortunately, those nasty compounds have been sitting in our environment since a long time ago, and they are still there. So where the exposure occurs, this is very heartbreaking part of the lecture. It happened mostly to the minority and the low-income populations, such as the Flint water crisis. That community is major African American neighborhood, and they suffer from the lead poisoning because the inappropriate design of those water pipes, right? And also, there's another case in Chicago. The children suffer from the lead poisoning. This is over 1 million children participating in this study. And hopefully after the Annenberg assignment, you will have an even better idea how those chemicals can harm humans, especially younger children. And people can suffer from the poisoning through the food consumption and the workplace exposure. And also the workplace exposure is disproportionately high among low-wage and minority workers. How do we manage risks associated with toxins? Government regulations are very important, and they can differ between regions. For example, United States EPA, regulate those chemicals under the 2 major laws, the Toxic Substance Control Act and Clean Air and the Safe Drinking Water Acts. And European countries, especially European Union, they use more stringent guidelines called REACH. This is in the Annenberg textbook. And all the manufacturers must submit a chemical safety assessment before the chemicals can be in the market. And many chemicals, such as BPA, BPA is a single block to manufacture plastics, and also phthalates, are more stringently regulated in Europe than in the United States. So how can we address those impacts? Through laws. President Clinton signed this executive order, and that's the first time to address the discrimination. And the Minamata Convention on Mercury mandates that lower income nations not to bear a disproportionate burden of disposal or pollution. So we have to address from the national level and from the legal actions first. This is one example when these pesticide chemical companies dump their waste in the neighborhood. There's a lot of people died quickly in the neighborhood, so they have to pay a lot of money to the survivors. But what happened to them? The dead people, they can never be alive again. So what are the most, so those are the chemical hazards, and then we'll talk about the physical hazards in the environment. So I put the slides here because we are living in the fierce wildfires, right? Colorado and California. And the statistics show that 84% of the wildfires are caused by human activities. And wildfires and disastrous events like hurricanes are examples of physical hazards. And other physical hazards are geological hazards like landslides, earthquakes. Okay, the earthquake can trigger tsunami. And in Japan, because of tsunami, the nuclear power plant exploded. And that was a horrible, horrible incident. And I want to point out here the landslides could be caused by human activities like deforestation and the mining.